Welcome back. We're here in Chapter 9, Producing Data, Experiments. We're now going to talk about how data are obtained. There's two different types. There's observational studies and experiments. Observational studies observe individuals and measure variables of interest, but it doesn't attempt to influence any of the responses. Literally, you're observing. Describe some group or situation. We call this ex post facto, after the fact study. Values of these variables are set before the study takes place. Whereas in experiment, we deliberately impose some treatment on individuals and we look at what the responses are. It studies whether treatment causes change in a particular response. Let's take a look at observational studies. The advantages here is we can detect associations between variables where the values of the variables have been determined. It can be used to study variables that are impossible or unethical to control. The disadvantages is we can't isolate cause to determine like a cause and effect. We won't be able to say that, but we can just say there's an association between two things. Now let's look at the different types of observational studies. We have a census. A census is we have all the individuals in a population and they're considered in this census. It records characteristics of all the individuals. So our sample really is our population. The advantages is that we have 100% certainty, and the disadvantages may be that it may be difficult to obtain and cost prohibitive. Another type of observational study is using existing sources. It uses data sets that have been collected. The advantages of this is that you save time and money. The disadvantage is that the actual data might not be applicable to what you're studying. And another type is survey sampling. It considers only a subset of individuals in the population. It records observed characteristics without attempting to influence the values. Now the advantages is that this saves time and money compared to a census, but it's very difficult to choose an appropriate sample. Now what about a designed experiment? Now an experiment records responses after we influence the values of the variables of interest. So variables have to be controlled, and we actively impose some type of treatment. Now, the advantage is we can really say that there's a cause and effect happening here, so we can have a causal relationship. Disadvantage is it can't be done if we can't control all the variables, and also if there's some moral or ethical reasons why we can't do something to someone or something. So I'm going to look at two different examples. We're going to see the difference between an observational study and an experiment. So, listen to this. Many studies have found, and this is problem 9.28 in Chapter 9, many studies have found that people who drink alcohol in moderation have lower risk of heart attack than either non-drinkers or heavy drinkers. Does alcohol consumption also improve survival after a heart attack? Well, one study followed 1,913 people who were hospitalized after a severe heart attack. In the year before their heart attacks, 47% of these people did not drink, 36% drank moderately, and 17% drank heavily. After 4 years, fewer of the moderate drinkers had died. This is an example of an observational study because we're not making people drink or not drink. We're just looking at what happened and taking note of what happened a year rather. So now let's see how it would be if this were an experiment. Well, let's look at how it would be differently phrased. We had subjects, healthy men 35 to 65. They were randomly assigned to drink red wine. 9 of them drank red wine. 9 drank white wine. 6 were to drink white wine and also take polyphenols from red wines. Then there were 9 subjects took the polyphenols alone, and 6 subjects drank vodka and lemonade. This is one where we have an experiment because we're actually asking them to do something, and then later on we'll see if maybe in a year or 5 years or 10 years, if we follow these people, we would see if any of them have any heart disease. This would be an experiment, like I said, because in other words, we had different treatments that we used on different people. So here we see experiment versus observational studies. In an experiment, we create differences in the explanatory variable and explain any resulting changes in the response variable. So there we have the cause and effect. Now with the observational, we talk about associations between the variables. So we observe the differences in the explanatory variable and notice any related differences in the response variable. Now, in an observational study, we do not control the variables under analysis, while in a designed experiment we do. Because variables are uncontrolled in this observational study, the results of the study can only be conclusions about associations among the variables. Now, groups may differ by characteristics not measured in this study. These are called lurking variables. Now, because variables are controlled in an experiment, the results can be conclusions of causation. So observational studies are useful tools for determining whether there's a relationship between two variables, association, but it requires an experiment to isolate the cause of that relationship. Response variable, when you learned this when you were doing other experiments in high school and things like that, they talked about a dependent variable, but since dependent means something else in statistics, we're just going to call that the response variable. The explanatory variable is what you're used to hearing being called the independent variable. So, we're going to talk about confounding. In addition to explanatory variables of interest, there may be other variables, explanatory or lurking, that make the group being studied different from one another. The impact of these variables cannot be separated from the impact of the explanatory variable on the response. So when we say confounding, it means we can't separate these variables. So what can we do? Well, if you're in an experiment, you can randomize subjects to receive different treatments. Your hope, and when you do that, you hope that the possible confounding variables would even out across the groups. And in an observational study, measure potential confounding variables and determine if they have an impact on the response. So in other words, we can adjust for these variables when we do the statistics. So let's look at an example. Let's say a common definition of binge drinking is 5 or more drinks at one setting for men and 4 or more for women. An observational study finds that students who binge have lower GPA than those who don't. Can you suggest some lurking variables that may be confounded with binge drinking? The possibility of confounding means that we can't conclude that binge drinking causes lower GPA. So this is problem number 9.3 on page 225. So what do you think? Well, think about this. What other habits might a binge drinker have? Now they could have bad diet, bad sleep, that could adversely affect their grade. The time that they spend drinking, they're not studying, obviously. So these things could be confounding in this particular problem. Now, if you remember the case study on the effects of hypnosis on the immune system, I'm going to flip through a couple of these slides and then we're going to answer the question at the end of it. So here comes our question. Whoops. Was that an experiment or was it an observational study? Well, because we put people into we did things to different people, this was an experiment. Now we're back to the weight gain spells heart risk for women. So let's look at the couple of these slides and then we're going to determine whether it's an experiment or an observational study. This one was an observational study. Because we didn't do anything, we didn't have them do an exercise program or anything like that, we just followed them and saw.